Hello students, we'll be recording formulas which are required in chemical equilibrium and ionic equilibrium. So starting off with the first formula that you should be recollecting is your Kc. Kc formula C raised to C D raised to D upon A raised to A and B raised to B. Do remember that Kc is called as equilibrium constant. The same formula also goes for QC, except for QC is reaction quotient which is calculated at any time t. Formula remains the same. Second, we could come across Kp, which is partial pressure of products upon partial pressure of reactants raised to their stoichiometric coefficients. Okay, next we could be talking about relationship between Kp and Kc, which is Kp is equal to Kc into RT raised to delta n. Okay, delta n, we all know it is C plus D minus A plus B. And generally the value of R that you are supposed to be using is 0.08205 liter atmosphere Kelvin inverse mole inverse. We'll be having your first is effect of concentration. Say if the concentration of reactant increases, reaction moves in forward direction. If concentration of product increases, reaction moves in backward direction, and vice versa. Okay, not going into much details. Second, if pressure increases, reaction moves in a direction where number of moles decreases. Similarly, if the pressure decreases, reaction moves in a direction where number of moles increases. Third is with respect to temperature. Exothermic reactions are favorable at low temperature, whereas endothermic reactions are favorable at high temperature. Okay. Next is effect of inert gas. If inert gas is added at constant volume, no effect. But this if it is added at constant pressure, okay, then reaction moves in a direction where number of moles increases. That should be it with respect to chemical equilibrium. Oswald's dilution law formula. The first one being alpha degree of dissociation, which could be equal to Ka into V, which is also equal to under root of Ka by C. Similarly, concentration of H plus is equal to alpha into C, which you could also be making use in terms of KAC. Same goes for weak base OH minus, which is also equal to alpha into C, which is also equal to under root of KBC. KBC से याद रखना आसान पड़ता है. W, which is ionic product of water, which is concentration of H plus or H3O plus into OH minus, which should be equal to 10 raised to minus 14 at 298 Kelvin. If temperature increases, Kw also increases. Do remember that equilibrium constant is a temperature dependent quantity that will also affect ionic product of water. Formula we could be having again with respect to Kw, which is equal to Ka into Kb, pH which is equal to minus log to the base 10 of H plus, molar concentration of H plus. यहाँ पे H plus ऊपर से भी आप सब्स्टिट्यूट कर सकते हो, ठीक है. And we have POH with us, which is minus log to the base 10 of OH minus. If you all are calculating for weak acids and weak bases, you all can make use of above formulas as well. If you are calculating pH for a resultant mixture, pH will be equal to minus log to the base 10 of resultant molarity. You do know how to calculate resultant molarity, which could be M1 V1 plus M2 V2 upon V1 plus V2 if they are acids and bases both. If the other, we could move on to the other reaction as well. We can even make use of formula pKa plus pKb, which is equal to pKw, which is 14. Buffer solutions. In buffer solutions, you could be having acidic buffer. For acidic buffer, you have the formula pH is equal to pKa plus log to the base 10 of concentration of salt upon concentration of acid. Generally equimolar mixture of weak acid and its salt with a strong base. Okay, similarly, if you're talking about basic buffer, you could have POH being talked about, which is pKb plus log to the base 10 of concentration of salt by base. Similarly, basic buffer would be a combination of weak base and its salt with a strong acid. Hydrolysis, do remember that salt of strong acid and strong base does not undergo hydrolysis. We have salt of weak acid and strong base, pH formula being 7 plus half of pKa plus log C. We have formula for KH, which is equal to Kw by Ka. We also have the formula for degree of hydrolysis, which is H is equal to under root of KHC. Now moving on to your salt of weak base and strong acid. Since it's a strong acid, the formula of pH becomes 7 minus half of pKb plus log of C. Salt of weak acid and weak base. You'll have to be very careful to identify or distinguish between buffers and these sums. KH will be equal to Kw upon Ka into Kb, and H this time is equal to under root of KH, indicating that H is independent of concentration for these purposes, for this salt. And your pH formula stands as 7 plus half pKa minus pKb. Molar solubility, which is in moles per liter, can be calculated as solubility in grams per liter divided by molar mass. KSP का formula x raised to x, y raised to y into s raised to x plus y. Just to show an application of this, we'll take a 1:2 salt. PbCl2 solid is in equilibrium with Pb2 plus aqueous plus 2Cl minus. जस्ट एक तेरे को याद आ जाए इसलिए तेरे को बताने के लिए, ये 1 तेरा x है, 2 तेरा y है, तो तू KSP जो है वो लिखेगा इक्वल टू 1:1, 2:2 इंटू s raised to 1 plus 2, which is equal to 4s cube. से अगर अपन 1:1 का सॉल्ट लेंगे तो KSP will end up at s square, and if you are taking 2:1 or 1:2, KSP will end up at 4s cube. 3:1 या फिर 1:3 का सॉल्ट लोगे तो KSP आ जाएगा तेरा 27s raised to 4, एंड 2:3 या फिर 3:2 अगर तूने लिया तो KSP will end up at 108s raised to 5. And the last thing that we could be ending up is your KSP and IP. If KSP is greater than IP, solution is unsaturated. Okay, if IP is greater than KSP, precipitation takes place. ठीक, fair enough. That's it, my friends. Thank you very much. Keep watching for other videos.